So before we move forward, I actually just want to double click on that because I think that's a conclusion we came to after last week. We've gave multiple examples of exclusive or unique data, and
Mhm.
it seemed like all the examples we had were about data that's like really attached to or relates to a contract instance.
Yeah.
So I think both the idea that you mentioned from last week and this week, they both rely on this idea that we can just kind of like bundle the contract instance related data, which is unique with the contract instance itself, and then we reduce the problem space to how to make the contract instance unique rather than making like all these arbitrary pieces of data unique.
Yeah, I think that simplifies it. I don't think it's essential to solving the problem, but it does sort of simplify the problem. In particular, it um, it means there's only one thing to think about, which is the life cycle of our contract instance, and we can assume. I think it's a fairly easy assumption that any contract that has sort of users, um, people are going to try and keep that instance alive. So the individual data elements hanging off of it, as long as there's a small number of them, it simplifies thinking about it a little bit. But where we wound up with was really this question of, can you um, somehow substitute for the proof of non-existence by arranging conditions constraining either the life cycle of an instance ledger entry, or somehow how it relates to other ledger entries in such a way that there's no way to ever create it twice. The risk, the whole reason there's this requirement for a proof of non-existence when you do a create, is that there might already have been a past version of this instance that then expired. It's now off chain. It's being held in an ESS or something like that, or in an archive, and so we want to be able to make it impossible for that circumstance to obtain, where you're recreating something that also already exists somewhere else. So the easiest thing we came up with was literally just to couple the identity of a contract with the expiration epoch in which it was created the first time. So this doesn't change its name over time, so long as you keep it alive. But what it means is that a contract's name essentially sticks the let's just say year, because we were thinking of this in terms of years, and evicting things on a sort of a yearly compaction basis from the ledger. And so if you assume that sort of every year there's a compaction epoch where we finally trim the ledger and get rid of the stuff that has expired, um, then each of those years has a number, right? The 2023, 2024, whatever. And if you were to sort of label your contract with which year it was created in, then the identity of the contract would actually have that baked into it. And so if you sort of quote unquote recreated a contract in a different epoch, it would literally have a different name. So there would never be a collision between the two. So if you accidentally had a contract uh, expire, you could, pay its rent and bring it back. No big deal. It wouldn't change its name. If you even had it evicted, you could restore it and it wouldn't change its name. That's all fine. So there's no name changing in this model. It's just that if you were to attempt to recreate in order to basically to hijack a contract, which is the sort of the attack scenario, you would never be able to, because if you were trying to do that recreation during the same eviction epoch that the contract was created in the first time, it would have the same name, but it would also, by definition, still be on the ledger. So we would see that you were trying to do a recreation and block it there. And if it was after that epoch, if you were 2 years later trying to recreate, you would actually be creating a contract with a different name. And so again, it wouldn't conflict. You wouldn't in any way be intercepting or confusing users or anything like that. And so that model, I think, is has a lot going for it. I think it's a very very appealing model. But on Monday or yesterday, Nico brought up a valid point, which is that it complicates a couple of use cases. So a couple of things don't work quite so well with it, and that's unfortunate. One is that the stellar asset contract um, synthesizes essentially an instance on demand for an asset pair, and in a more general sense, there's a sense of factories, that there's these sort of pattern in smart contracts where there's a factory that synthesizes other instances. And in both those cases, the factory, either the SAC or the user provided factory, is going to be creating contracts based on some contextual criteria, some identifier that it has provided as inputs, but that don't definitely identify a let's say year of creation. And so you could have, for example, some of your SAC generated contracts would be marked as this year, and some would be generated as last year, depending on which year they actually got instantiated in. And then from a multiplexing perspective, it's not quite so obvious to either a user, or if you treat the factory as a multiplexer that routes requests to lazily created instances based on their identity, sort of which of those names it should route to. And that is true. That's an unfortunate problem with that approach. So we kind of went back to the drawing board, and over the last 24 or 48 hours, we've been batting around other ideas. I had an idea yesterday that involved coupling the state expiration to the longest lived of the mergeable entries, such that your contract would outlive any of its accounts, sort of to summarize. And that would be accomplished, basically through a reference counting or garbage collection mechanism, which we're actually already on the hook for in the bucket list in terms of we're going to be keeping WASMs alive as long as they're referenced by instances. So this would just sort of generalize that pattern to keep instances alive so long as they're referenced by any mergeable data or any ledger data entries at all. That would keep the owning instance alive. That has certain that kind of turns the whole problem on its head and changes its nature entirely. So it's not eviction is not time based in that picture at all. Expire is still time based in that picture, but eviction isn't. And so that would have at least the benefit that it would be impossible to have a revived contract sort of taking the place of being able to read and write live data on the network, because it never would have it never would have been evicted. The contract never would have been evicted in the first place if there was still live data on the network. Now, you still do have the possible weird attack scenario where someone revives a contract that all the data has expired and been evicted, and the contract has been evicted, and then they revive the contract, and then they revive all the data. And so it doesn't completely solve the problem. I haven't actually given it a lot of time in the last 12 hours to think through that sub scenario, but that's sort of where I'm at, is thinking in terms of those, or even I still honestly I think there's something to the epoch model. But anyway, I've been talking for 15 minutes. That roughly gives you a picture of where we're at on this topic. Obviously, this is a fairly disruptive last minute change to the set of design considerations going into data expiration, but I think, and I know Lee feels very strongly about this as well, and we actually, I believe Tomer and Nico sort of echoed our concerns that operationally, the thing where we have to keep a hot, high availability, low latency server online just to do create seems like painting ourselves into a corner that we may not want to be painted into. But that's that.
Yeah, I definitely think that the proofs of non-existence are definitely kind of like a pain point in the current design, and it does make sense to figure out a way around them. There is one case that I found the Epoch design from last week to provide a good solution for, and I'm not sure that the current proposal does. So I just want to raise this. We have I think it's one thing to have like a DeFi protocol that caters to like many accounts. But sometimes you have kind of like a contract that is super small scoped to like an individual user, for example, like a smart wallet contract or a multi-sig wallet. And in these cases, if a wallet gets evicted, then it could be, in theory, recreated with a new, with new signers or a new admin, Whereas I think with the Epoch version from last week, that wouldn't have been possible, and I think that this last proposal does make that possible. Would that be a correct observation, Graydon?
Yeah, I think so. I think there's some need to have a, a degree of finality that is still missing. Yeah, I need to think about it more. I'm sorry. I've kind of been doing a couple other things most of the last day, so I haven't. Most of the stuff is not in my brain right now.
But I do wonder if there's a possibility that instead of kind of like codifying the epoch into the contract address, like the developer could provide arbitrary data that can go into the contract address. For example, if there are a set of um, kind of like constructor arguments that define the kind of like the core functionality of the for example an admin, and codify that into the address, would that help with these situations?
I mean,
Sorry, Grayson.
go ahead, Damon.
Yeah, because we just discussed this with Sid for a while, and basically the fundamental issue is that well, in the first like to answer your question, Tomer, like we do have the salt parameter, which can be a hash of arbitrary data, which would basically make the contract instance reasonably unique, and we can extend this and provide more guarantees. Basically, the fundamental issue is mutability, right? So as long as your contract state that you consider to be unique is immutable, it has one-to-one mapping to the contract ID, and it is also like it also has to be authorized by someone, and basically the recreation will be possible only by exactly the same party with exactly the same parameters as at the instantiation time. So if the contract global state was immutable, that would be enough, right? Because contract ID would be a function of the immutable global contract state. The issue is that global state is or can be mutable, right? So simple example is a token, right? Let's say you create a token as user A and you set user A as an admin. So basically contract ID is created by user A, right? And it's codified in the contract ID. Always nice and good, right? But then let's say in the middle of existence of this token, you set token admin to user B for whatever reason, right? And user A shouldn't have any permissions over this contract. But if the contract expires, user A as owner of the original contract ID can recreate it and set themselves as a token admin, thus effectively taking over the token, even though this wasn't intended. So basically, with this model, whoever creates the contract ID is kind of a super user to some degree of this contract, in the sense that they, like, if the contract expires, they may recreate it with whatever necessary state. And the same goes about the implementation, for example, like contract has been updated, it can be reverted or updated to whatever else. So basically, any sort of mutable changes past the contract creation can be rolled back, at least. And in some scenarios, this might not be necessarily tried if you're talking about some protocols where like multiple users need to vote to mutate the contract and whatnot. So there we kind of have this entity that creates contract having this sort of special permissions, which is a bit annoying. I guess it would work in a lot of cases, but in some cases it just cannot work because contract may have different requirements on mutability and management.
So, any suggestions on which direction to pursue right now?
So I have actually some additional ideas, from where we left it off. So I think that maybe can help here. So, like the type of thing I've been thinking about is is that right now, yeah, like when we've been talking about like some of the properties that are nice, right, with this kind of unique ID thing, right? I mean, setting aside for a second the issue that Dima just mentioned, where you have the admin in the like if you allow IDs to be reused somehow, then you're kind of in this kind of band that you have to you potentially roll back state, right? So the alternative is to have this global state attached to your instance that can be sent to the to like this to be evicted, right, of the ledger, but then you have to ensure guarantee that that this ID will never be reused, because the only way to restore it would be from that long-term storage place, right? Anyway, so like where I was going with this is that, and that goes back to like this those factory, like those patterns, right, where you have like factories that are actually the ones spinning up contract instances, where we do have actually today we already have control of the instance ID from factories, because that's where you define what the salt is as part of the instance. So in that context, you can already today, without any design change, you can actually decide to incorporate or not the this unique ID, I mean the epoch, whatever the epoch means, right, in your instance ID. You can already do that today. So I think maybe like one of the missing kind of building block here in a way is how can we make sure that your factory itself, your factory contract, is going to be stable in some way. Because I think once you have if you, let's say, depending on the contract, like an AMM type of contract, right, that follows a factory probably wants to have stable IDs for the pairs, right, for the instance pairs, because that's actually an area where it becomes extremely difficult to deal with like you have to basically make a decision. Do I need to create a new pair or not, like a new instance for a specific pair or not, kind of on the fly, and you want to avoid having a directory of sorts of like source of truth, right, that's off chain, that basically says here are the list of the official pairs, because that kind of defeats the the whole idea of having a decentralized place where you know exactly like which are the official instances for this AMM.
But I think at the same time, though, if you have such a factory, it still has to decide when it receives a request whether it is going to service that request by creating a contract or not. So
Exactly.
it needs to have some map that it's storing that says this contract exists, this one doesn't, and it could just as easily say this contract exists with this salt, this one doesn't.
It's just from like the admin, like the type of data that you have to decide and all this, I think might not be as constrained in that use cases if you have control over the policy, basically, because depending on the type of contract, I think you can decide, okay, do I want to have this ID, like the epoch, baked into the ID or not, right? Into my factory. Like that's, you can decide that there. The thing that maybe the thing that we need some control of, or that we need to maybe allow people to have some control of, is when you do want to use an ID that is not with an epoch in it, right? So like maybe you, for whatever reason, you cannot use an epoch because you can't trust your users or something. Is there a way in that case to go back to have to require proofs, right, from this long-term thing? So basically, it becomes like more like an opt-in in that case. right now we don't have. So the thing I'm getting to here is that right now we don't. When we create a contract instance, we don't control in which what type of entry on the ledger it is. Is it a unique thing using our nomenclature, or is it a recreatable entry? The thing we've been bouncing off is like, okay, right now in the current design, right, it's unique, and that's annoying because basically that makes all those instances unique. Therefore, you have to have a proof of non-existence for any instance, and this is extremely annoying. What if we were giving control of that to contracts? So like basically when you spin up an instance, you get to decide, do I want it to be unique or do I want it to be recreatable? And combine that with the proxy pattern. And now you can actually do all sorts of interesting things because from the contract logic, you can basically decide, like depending on what your contract does, where it stores state and all that stuff, if you're going to require a proof or not from the, that is kind of the baked into the network. Or maybe in some cases, you can actually rely on some other thing, like maybe the proof that you need to kind of get around the uniqueness problem is not a first class kind of proof. It's more of a lighter weight proof that comes from an oracle of sorts, right? And that in that case, you can still create on network an instance that is a recruitable instance, but where the contract is actually in control of deduping. Like it may actually decide to not spin up a new instance if this oracle tells it to not to do that. Like how would people feel about this kind of solution where we basically bake into the instance ID, where basically we would have the new argument, right, to the create instance that is, is it a unique or recruitable thing? And then at that point, the DApp is basically in control of what is expected there.
I think given that you're already providing salt, you kind of already have
We already have some level of that. Right now, we don't control. We don't control the is the proof required or not?
Right, but part B of what you're proposing here is that we don't have a built-in method of proof at all, and so again, there is no method of proof that customers.
No, we would have still a built-in one, right? We still have uniques. It's just right now they are mandatory. I'm saying make it an argument.
Okay.
Make it an argument. It's basically a way for, in some cases where you need to fully, I see decentralization as a slider, right? Like for the different apps. Like some people don't care, some people care. Maybe the type of level of control they want there is going to be actually managed by a DAO of sorts, and maybe that DAO has a way to give you those lighter proofs. And then you have like the more extreme thing that is it's the layer one, proof system, and that one is going to be probably quite a bit heavier and probably more expensive.
I guess I only see two actual results from this. One is that your factory keeps let's say you're an AMM and your AMM is a factory for every pool, right? And so it's going to keep a map of the salt that it used to create asset X to Y. And if anyone asks for asset X to Y, it'll check to see if that's there. And if it's not there, it'll just recreate it using the salt it used last time. or it'll restore using the salt that you used last time, and it will never create it in a new epoch, right? So that's sort of in the identity of the that makes the concept of an epoch and the concept of a salt identical, but it's controlled by the factory, and it's just sort of, we just have to keep it as a value so that you don't have to guess which salt to use. It's maintained by the factory, and then that just pushes the question back, though, which is that how do you maintain the longevity of the factory? How do you keep the factory itself from expiring and being recreated? And that is your plan B here, which is that the factory uses some kind of a heavier proof. And so then the two options that you're talking about having is, one, we build a proof system into the network, and the other is that we tell users, we're not going to provide a proof system, but you can use your own Oracle, which is the same thing, which is, a slower, lower availability version of the fast, high availability proof system we were talking about. The Oracle may not answer, right? And so then you can't create your AMM multiplexer until the Oracle does answer. And why do you trust that Oracle to track recreations for you? If the Oracle lies, then you're in trouble. I mean, I don't know that it actually fixes the problem. It kicks it down the road a lot and makes it easy for people to get it wrong and have to write a lot of software to get it wrong. I would like something more built in.
The thing is that for the factory, right, the difference is that if your entire system relies on making sure that this factory doesn't get doesn't default on rent, right?
Yeah.
I mean, it's one thing. It's the one thing that everybody kind of relies on. So I think at that point, the even like low tech things like having, somebody somewhere, anybody, bumping rent on that one thing seems much more likely than when you have that per instance.
I totally agree.
It's critical to your DApp.
You still have to have an answer for what happens when everyone goes on vacation for a year, because people do.
But that's why I said, like, you can have this go into the long-term archive. That's okay. That's your insurance. You have to basically make that thing unique with the unique definition that we have today, not the new unique way using epoch.
I don't know why it's better, but okay.
Yeah, it seems to me like we made kind of a full circle, right? From the proposal of getting rid of the unique storage to proposal. So let's not get rid of unique storage, but make contract creation optional. Like the storage type an option. Which, like, if you have two storage tiers, then I agree. Like, why not add a flag? That said, like at that point, why do we even bother like removing anything? Let's just have unique storage if we feel like it's necessary, and it will be necessary in some cases. Then we just make it available. It's in current design, and just add the flag to the create contract function, and contracts can do whatever. They can use unique, they can use non-unique. So it kind of didn't simplify anything, did it? It just maybe fine, right? Maybe we cannot simplify this version. So then, well, what are we discussing here?
I mean, I guess maybe there's another thing here that we can do is that for the factory, when it gets instantiated, it would actually have the maybe the epoch is actually baked into its ID, and the way it was generated, and then if somebody else was going to respin it up, it would get a different epoch. So that, I think, implies that there would be maybe a static method for the WASM. I mean, that's something that I actually have been discussing in the, before. That is like, maybe this is actually a case where you do not want you want to kind of take away some of the control of the caller for the factory to control the salt. Like you want the contract itself to have some control over that. Basically, always add the in this case, you would always want to have as part of the salt the epoch, and I think that solves the problem for the factory contract, because there's no way to recreate it with the same ID. Like somebody cannot do that.
Nico, are you generally thinking in a direction where basically like every contract developer needs to write a factory contract for their service?
This is, I mean, like not necessarily. I think looking at this, the problem with the typical, you know, like the reason that we talk about factories, because this is actually the way a lot of contracts work in DeFi. Like, you know, you look at like the you know, AMM implementations. They actually have an instance per pair. They don't have like a, you know, because and the reason for that is you want to have control. I think that one of the main reasons is probably to have control over upgrades, so that you don't have to upgrade the whole your entire pool of you know, all asset pairs basically getting upgraded at the same time, which is kind of a risk. But no, like where I was getting to is that by analyzing this specific problem, you get into a place where you want to guarantee, if you want this epoch, let's say, right, in your ID, you have to guarantee that the epoch is actually part of it in some cases. And the way to do that would be to have I think a static, like what I would call a static factory type of method for that contributes to the ID when you instantiate.
Okay, so I think we went deep and there are some new ideas surfacing here that I think we probably need to get in writing and to evaluate asynchronously, because it's a bit hard to follow through all of these things right now. So I think, Nico, if you can kind of like outline this kind of like factory plus Oracle approach that you're referring to here, I think that could be beneficial. I know Lee also has some opinions in the matter, but he's not around today. And I do want to mention for everyone else here that the dilemmas and the design questions we have are around exclusive unique storage, and in terms of temporary and mergeable, we're pretty much stable. So you know, feel free to build on that. And so I recommend that we regroup, try to get to a resolution asynchronously on Discord, hopefully by beginning of next week. And potentially discuss this again in next week's design meeting. I do want to talk a bit about the token interface, which is something that came originally from Dima. I started a thread in Discord last week around the question of allowances. Should allowances be temporary? Because obviously our standard token contract, our started token interface needs to have some opinions around what type of storage allowances use. We've already kind of like agreed upon that balances will be mergeable. And I think both Dima suggested and I agree that we can make the allowances temporary. That means changing the interface so that when a user allows, calls the allow function, which gives someone access to an allowance, they need to specify an expiration date on this allowance or expiration ledger, and that needs to be lower than what the max time for temporary entries are. So just want to solicit some feedback on that. Dima, do you have anything else to add on that?
Yeah, I actually said you propose this, but yeah, I'm kind of fine with this idea. What I wanted to say is that currently we have this increase-decrease allowance interface where you kind of modify the allowance value instead of overwriting it, which is in response to certain issue is using allowances in the ERC20 where the set interface can be pretty confusing and lead to spending, like someone spending more than they should be in theory be allowed to spend. That if you make allowances temporary, this increase-decrease logic no longer makes much sense because, well, what if you increase, like what happens to the time limit? And what do you do if you have like 5-minute allowance for $10 and say 1 hour allowance for $20? Like how you add them up? Do you maintain them separately? So I suppose like more or less straightforward option here is just to go with the ERC20 approach where we just have a single set allowance or approve or whatever's needed function that basically resets the value, which is I guess error prone on one hand, but on the other hand, in general, the hope is that on Soroban, allowances should be used for very specific use cases. They should be much less prevalent, and hopefully for the cases where you do set some allowance, shouldn't actually matter much that you do overrates because it should be limited to something like, I don't know, subscription or something like that where yeah, there shouldn't be any frequent allowance withdrawals and things like that that might interact poorly with reset methods. So, I don't know, that's what I'm thinking about it.
Okay, so to reiterate, we're still assuming that allowances won't be required for most simple cases because AuthNext takes care of that. And we're proposing to take the current token interface, which has increase allowance and decrease allowance, and unify these into a single allow function, similar to what ERC20 does. And we're going to add to this allow method an expiration ledger for this allowance, and that expiration ledger needs to be lower than the max expiration ledger that temporary allowances are allowed to have. Temporary ledger entries are allowed to have.
Can we maybe like I'm still not following why like the absolute set is better. I mean, my understanding of why this was changed on top of ERC20 is because you have actually a race condition, right? Where you have a flow that basically says, oh, I need for this contract invocation, I need $10, right? Of to do something. So I'm going to just say add $10 to my allowance, call the contract, and that's kind of it, right? And then that can be executed in parallel to other flows. Whereas if you do absolute, you end up with, I think the original problem, which is, I mean, basically like a race condition, right? Where you end up reverting your allowance to something that maybe you don't want. And that's in the case of failure, I think that this is especially bad because you have like add, if you reset your allowance to what you thought was the before state, but now you're actually just canceling some other parallel flow that is happening.
Yeah, I guess the argument here is that like this should be very rare if happen at all, just because of the use cases for allowances are much more narrow, and in general, like there shouldn't be a good reason to set multiple allowances for the same contract in parallel and also do some contract operations in a very short burst of time, because this is like just normal next case. Like, why would you bother with allowances just do transfers?
Well, those are more like I think the use case for that is like when you cannot do a single transaction, right? Like if you have to split up your allowance and actual contract execution, So like, if we're going to have something to complement the scenario of like real-time transaction, why not? I think this was discussed too. That was like, why not have like actual, and I think that's the way actually, like when you get your, with credit card systems, let's say, right? Like if you pre-authorize something, you get an ID back, and that's actually your business logic actually uses this allowance ID as part of your, of the flow instead of, so like that's actually much better, right? Like you have a unique ID per allowance.
Yeah, I think I suggested that as an option as well. I don't know what is the general opinion on that, but yeah, like temp allowances kind of make much more sense if they just had an ID, and then you could just only revoke it, for example, or maybe modify it if it deems it's needed. And then yeah, users of the allowance would need to use an allowance ID instead of just transfer from. Yeah, the downside, it makes the interface more complicated.
So just to be on the same page, the suggestion here is rather than having a specific, like a single allowance for a tuple of like a from and two addresses, you can actually have multiple ones that are allocated for specific uses.
It sounds like we're making something that we're saying won't be used often, like even more complicated, right? I think we just said that like allowances are, allowances won't be used very often. Is that right?
Well, I guess then complexity is not too big of an issue, right? It's like more advanced feature. I don't know.
Well, it's like, I think the trade-off here is that if we think that, yeah, we need some way to do something like allowances outside of the normal flow, can we provide something that is secure, right? And not error prone. I think that's where, like, to me, like saying, hey, we're going to use the original ERC20 absolute thing, which is actually had some of those issues. Like, why would we do that in that context?
So the main reason we're trying to move away from the delta functions, Nico, is because when you switch to a temporary ledger entry, we have some kind of like issues at the boundaries, right? Like, what if I, have an allowance and I submit an increase function, but actually by the time the increase makes it, my allowance has been evicted, and now I end up with less total allowance than what I thought there would be there.
I get that. It's more like if we're going to add a system that we think is going to be kind of resilient to those type of timing problems, we should probably do something that actually is solving that problem in a broader sense, which is, I think, what Dima mentioned in the past, to have like to have to pass some, to actually associate allowances to IDs, and then you just have to pass that around if you want to use this API.
That is a possibility. I'm afraid of like moving too far away from the ERC20 model, because that's something that people have like a good grasp on. And this idea of having like ID'd allowances is just sounds more powerful, but it also is more foreign.
Another easy option would be to, we add this approve call, but we don't allow reductions with it, and we just add another function that lets you clear an allowance, right? Like that would let you bypass this vulnerability without making the interface that much more complicated.
I think in the example of the vulnerabilities that you've attached to some threads, it was actually about decrease not working properly. I'm not sure.
Yes, I'm saying like the vulnerability is when you try to decrease, but in that process it actually gets spent, and then your decrease actually becomes an increase, right? So I'm saying that like you like the approve won't let you decrease the existing allowance. So if it does disappear, right, then that thing will fail. Yeah. So Mooch just mentioned like one of the solutions here is you could also just use approve, but go to 0 first. But that's on the we're passing the burden of this onto the user, right? But that is a solution from the user's perspective, that you always go back to 0 before increasing.
I'm not necessarily sure if this solves something, to be honest, but I may be missing something. I think like if you set an allowance to 1,000 and then someone spends it and then you set it to 0 and then you set it to 300.
Actually, yeah.
Exactly the
Right.
same issue as if you just set it to 300 after someone has spent 1,000.
Yeah, you're right. That.
So like this would.
Yeah, it would still have to be an increase. Yeah.
Well,
yeah. Never mind. That doesn't work.
Okay, so I just want to clarify the options here. There's the option that's on the table right now, which is just to migrate to a single approve function instead of increase decrease allowances. But we're concerned about some vulnerabilities around the edge cases. So one other proposal is to have separate ID'd approvals or allowances, which would get around that problem, but is kind of like moving away from the ERC20 standards. And then there's, I think, so Sid, did we decide that clear is an option or not an option?
No, that doesn't. I mean, that doesn't really work. It's the same thing as just setting to 0 first, which would work. But you could still misuse this, is the point, even if you had the clear.
Okay. Cool. So it sounds like we need to make a decision between these two options. Dima, I don't think, do we have the option, the ID allowances option written down anywhere?
Probably not officially, no. And I think a big issue is ID allowances is how the ID is generated. Don't have a good answer for that. I suppose it should be off-chain because otherwise you need some auto increment, which is a problem. So that's kind of an annoying technical caveat of IDs. So basically, it requires kind of more design work to figure out how exactly it could be done.
Yeah, there's definitely a handshake problem where if you have two parties, they have to know about the ID.
Yeah, I think it also requires there's some downstream issues with that as well, where right now it's very easy for a user to figure out exactly what's their allowance for a specific contract. Their wallet could easily display that. Whereas if you have like multiple ID'd ones, now we are depending on some indexing service that actually aggregates these. Okay. So I think, Dima, we probably need kind of like a quick write-up on what that looks like, if you can dump that in Discord, so that we can have a better understanding of all the problem space. And yeah, any other comments in the topic?
I mean, like, yeah, I guess the root cause of all this stuff is I think of like allowances that are aggregated like that per contract. I mean, you allow parallel invocations, right? I think this is going to end up with you actually defeat in some way the allowance model. Like if you don't, because the flows actually happening in parallel means that if you think you're doing, let's say you're giving $5 for a specific transaction, and then you have a different transaction that needs 10, and in parallel, you end up increasing the allowance to 15. And well, the first time you're invoking, like let's say you are invoking this for the first one that only needed 5, now you're actually exposed to 15 for that invoke. So I think in that world, neither version is actually great in terms of like protecting you against exposure. So it's kind of defeating allowances to do parallel execution, I think. Like the only way to do parallel stuff is with the unique ID, really. Like if you really want to limit your exposure.
Right, and our expectation is that for like these simple cases, off next will be used, which is kind of like more suitable for parallel execution.
Yeah, I think it's more those are more like for those cases where you cannot do synchronous, span. And right now, like it's really unclear to me, like what is the like if you need that thing, right, where you need to go basically span transaction boundaries, you're now talking about probably minutes, while you have those spanning allowances. I mean, minutes or more, right? It could be like hours or whatever. And if you do parallel execution, I mean, parallel flows in that context, I mean, it doesn't work. It's a broken model.
Okay, so this needs some further explanation. We're at time and we haven't made decision today, but that's okay. Any decisions, but that's okay. We made some progress. So we have some follow-ups and we'll do these asynchronously and reconvene next week. So thank you all. Appreciate your time and see you online.